Okay, today's topic, what is an equation? Okay, and with that topic, we're going to do some visual things, and we're going to do some test prep things, and we're going to do, excuse me, I mean, okay, thank you. Some written work to all go together with this idea. What is an equation? We can go by definition and things like that, but before we do that, let's go ahead and apply the idea so that we can turn around and figure out what exactly that is. Okay, in this container, I have 6 apples, okay? I have 6 apples, and I have 3 cups right here. I want to equally distribute my 6 apples into my 3 cups. How many apples am I going to put inside each cup? Again, I have 6 apples. I have 3 containers right here, and I want to put an equal number of apples inside each container. How many apples am I going to put inside? Okay, 6 apples. Well, let's start with the first one. I can put one over there. I can put one over here, and I can put one over here. And I notice I still have 3 apples left, so I'll put another one here, another one here, and another one here. And guys, it looks like with my 6 apples and my 3 cups, I had 2 apples inside each, I keep saying cup, inside each container. So if I have 3 containers and I have 6 apples, I can put 2 apples inside each container and it comes out equally, okay? So then that is the idea behind an equation, so we'll go ahead and do one, but let's do another example first, okay? So I had the 6 apples, I had the 3 containers, and I put 2 apples inside of each of my containers, okay? This is probably why I was saying cups, because I knew what I wanted to do next, okay? 1, 2, 3, 4. Okay, guys, here I have 4 cups, right? I have 4 cups. And inside my measuring cup, I have 32 ounces of water. I have 32 ounces of water, and I want to pour the same amount of water inside each cup. How many ounces of water would I pour inside each cup? What does this idea, just like the last idea, entail? Guys, it entails multiplication and division facts. I'm saying multiplication and division because a lot of times we'll say, oh, I know my multiplication facts. Well, guess what? You also know your division facts if you know your multiplication facts. Those are inverse operations. We think about the Hermetic principle number 4, the law of polarity. Everything has, its opposite. So we'll get into that a little bit later. But again, guys, I have 32 ounces of water and I have 4 cups, and I want to pour an equal number of water inside each of my cups. How will I know how many ounces to pour? Now, I could pour 1 ounce, 1 ounce, 1 ounce, 1 ounce, 2 ounces, 2 ounces, 2 ounces, 2 ounces. I don't want to be here forever. I want to know what relationship do 4 and 32 have if the equal or even part, has to be addressed as well. Let me think. 4 and 32. Equally and even. I can count by 4s until I get to 32, or if I know my multiplication facts, which means I know my division facts, I can take that 32 and that 4. I would divide those 2, and I would say, I know 8 ounces would be inside each cup because 8 times 4 would give me the 32, and 32 divided by 4 equals 8. Okay, so guys, I will do that. I will pour 8 ounces into this cup. Excellent. I will put 8 ounces into this cup. Oh my goodness, guys. I will put 8 ounces into this cup. And I will pour 8 ounces into this cup. Don't look, don't look, don't look, don't look, don't look. It's 8-ish. It's 8-ish. It's 8-ish. It's 8-ish, 8-ish, 8-ish. Bam, 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 guys. We did that. And so now, inside each of my 4 cups, I have 8 ounces of water because inside my measuring cup, we had 32 ounces, and 32 divided by 4 equals 8. 32 divided by 8 equals 4. 4 times 8 is 32. 8 times 4 is 32. Plethora of ways that we can do that, okay? So then this is the idea or the premise behind what is an equation. Especially for our younger children who may be visual, or when you're first introducing the idea and someone may need to know what does this concept look like before we move into, bam, the mathematical representation, okay? And so let me pull this up just a little bit to make sure you can see it. I know there's a small glare there, okay? Here is an equation. 5 times box equals 35. That box is just an unknown, and with our smaller children, we start with that box. And then when you get older, we'll move it to a variable, which means this x won't be here. So we don't want to start confusing anybody, so let's not mention the variables just yet, because otherwise, if it's a variable in the box, is that a double variable? Hey, we don't know. We're not going to do that right now. It's not even going to matter. So guys, again, here we go. Here is an equation. Here is an equation. 5 times x equals 35. Okay, so at this point, I am going to turn this around, not me, turn this around so that you can see exactly what it is I am about to do, and you can follow along with me, okay? What is an equation? What is an equation? Okay, here is an equation. Okay, so 5 times x equals 35. So here is the question, and this is a 3rd grade sample, guys, from a one of the state mandate tests. It says, what number goes in the box to make the equation true? Here is an equation. So that part is given. The question they want you to answer is, what number goes in the box to make the equation true? I found the source of the glare, so let me get rid of it here. And I think when I come back, you all can tell me what number goes in the box to make the equation true. Okay, guys, let's do it. 5 times x. Again, if I know my multiplication facts, I can say 5, 10, 15, 20, 25, 30, 35. Wait, how many times did I count by 5 to get to 35? That's going to also be my answer that's going to go in the box. Or if I know my multiplication facts, I also know my division facts, remember? So if I look at 5 and 35, I'm thinking, what relationship do 5 and 35 have? Okay, if I think about multiplication or division, I know that 5 can go into 35, or 5 is a factor of 35, or if I do something to the 5 enough times, I can get 35, and that's where the multiplication and division, again, those polarities come in. So I can either do that, 5, 10, 15, 20, 25, 30, 35, and I know that's 7. Or I can say 35 divided by what number is going to equal 5, and that's still going to give me 7, okay? So inside my box, I will put the 7 because the question asks, what number goes in the box to make the equation true? Thank you so much, Yamina. You are so awesome. It starts to get dark is because she has turned off all the lights and all of the blinds are now closed. So this may work. We shall see. So again, when we have these standardized tests that our children have to take, guys, all they're going to do is change the number, but the concept, the idea is going to remain the same. So that is why we push for our children to know their multiplication facts. So when they say here's an equation, and they give you 6 times x equals 42. We can say, wow, what relationship do 6 and 42 have when I'm multiplying? Or what relationship does 6 have with some number when I'm multiplying to get to 42? Or when have I seen a 42 and a 6 together when I'm multiplying or even dividing? Again, those inverse operations, that polarity, again, we'll get to that. So then I'm going to either have to know that 6 times 7 equals 42, or I'm going to have to multiply by 6. So if it says 6 times, that means there's some number here that once I multiplied it by 6, I got 42. So you're going to